what are the issues in paralleling two or more number of batteries in parallel? You know that in case of lithium batteries, large number of small cells, for example 3.6 volt cells, they are connected in parallel, a large number of them, hundreds of them, to increase the current capacity of the total battery. But when you do it, there are some issues which will affect the lifetime of the battery itself. So therefore, I want you to understand the issues involved. So to consider that, first let us understand what will happen if you connect two batteries in parallel. Let us take an example. Take a car battery of 12 volt and a car battery of 6 volt and connect them in parallel. What will be the final output voltage when you connect them in parallel? I used to ask this question in the interviews to many students, and almost 100% of them never answered correctly. Okay, can you answer? Will it be 12 volt output, 6 volt output, or something in between, let's say 9 volt output, or none of the above? The answer is none of the above. And let's see what is the actual answer. If you draw the equivalent circuit for a battery, inside there is a battery voltage and an internal resistance. For the two batteries I have written Ri1 and Ri2 as the internal resistances and 12 volt and 6 volt as the voltages. And when I connect the two batteries in parallel, so it forms a circuit for the current flow. The 12 volt will force a current through, and how much will be the current? For the given example of 20 milliohm for Ri1 and 40 milliohm for Ri2, the current will be calculated as 12 volt minus 6 volt divided by the total resistance, which is 60 milliohm or 0.06 ohm. This comes as 100 amperes. Now 100 ampere is flowing between the two batteries itself. It is not available for the output. So this is one problem, which is the internal circulating current. Now what will be the output voltage? So it will depend upon this current I. So if you calculate 100 ampere in 40 milliohm will develop around 4 volt DC across it. So that the total voltage will become 6 volt plus 4 volt, which is 10 volt. So answer for this case is 10 volt, but it will depend upon the Ra1, Ra2 values. And also the current also depend upon the Ra1 and Ra2 values. So if you are going to connect a large number of lithium cells in parallel, such circulating currents will be happening from one battery to another battery, and the energy is wasted. The energy, in this case, for example, the energy in 12 volt battery will get lost as heat in the two resistors. And so now how to avoid this? How to avoid the circulating current and how to save the cell so that it will give longer lifetime? To avoid the internal circulating currents and to avoid decrease in the lifetime of the cells, number one, connect all cells with the same voltage. So if in the previous circuit, if the two voltages are equal, then the current will be 0. So we have no issues, right? And but how do you know two batteries are having same exact voltage? We will have to actually measure it physically, and there are machines available which can automatically sort the different cells having the same voltages. It will put in different trays, and not only the voltage should be same, the internal resistances of the batteries also must be same. So automatic machines in a battery making factory are available which will sort these cells in one go for manufacturing purpose. For example, this particular tray will have all cells with the same voltage and same internal resistance. So we can connect them in parallel. So now we saw that connecting in parallel is having issues, particularly of the lifetime. And how to solve this issue, particularly when you want higher current. For example, for the electric vehicle, you need large power and large current. So one solution is that you go for what we call as prismatic cells. Now the prismatic cells will have the same voltage as the cylindrical cell, but the current capacity of this will be very high. For example, this is only around 3.4 ampere or 3400 milliampere hour H, whereas this prismatic cell is having a capacity of 302 ampere hour H. So you can take one big prismatic cell, a number of them, and connect them in series to make the final battery voltage. So for electric vehicles and energy storage systems, therefore the recommendation is that you go for prismatic cells, and you can connect a number of them in series to get the required system voltage. System voltage typically may be around 48 volt in some systems, or it can go up to 1000 volt or even up to 1500 volt. Particularly if you want very high power, for example, the energy storage systems are available with a power capacity of 2 megawatts, and the energy storage capacity of batteries are available which can work up to 5 megawatt hour. So now how to make such huge batteries, what we will be doing is that we will be putting a number of batteries again in parallel. So it is you series connect and make one battery, and several such batteries can be paralleled. But when you parallel multiple batteries in parallel, there are issues. Therefore, we need to control problems. So for that, what you do is we have what is known as battery management systems, BMS, and the BMSs are controlled by a master battery. And how does it control? There is a signaling link provided between the master battery and the other batteries. Normally just two wires run through, and the micro circuits which are there in each battery, they connect to the two wires, and the signaling happens on the two wire, and the signaling used is called CAN signaling. So by properly monitoring and controlling the BMSs of each battery, we will be able to make huge systems which can give megawatt hour capacity. So we will see later on in electric vehicles as well as in battery energy storage systems how we do, and I will also explain you what is CAN signaling later on. Thank you.